Hello everyone, my name is Jack. This is my presentation of my research report of the subject called COMP 90043, Cryptography and Security. My topic of my project is Security in IoT, research of concerns in the industry and the approaches. Well, the outline of my presentation including 4 sessions. The first session, I will introduce a bit background information about the definition of Internet of Things and the lightweight cryptography. Next session, I will introduce the existing algorithms, including present, T, and a bunch of others. In the third session, I will introduce the parameters I use to evaluate the existing algorithms, and finally conclude them into 2 classes. That's disadvantages and advantages. My last session is a Q&A session. I will take the questions from the audience and answer them. Hope you guys enjoy my presentation. We can consider Internet of Things easily as a sensor network. The technology uses the sensor to sense the data from all across the sphere and collect them. And the process will be executed in the main node. After the process, these smart machines can communicate and interact with other objects deployed in the surrounding. Well, the main issue here is that we always can have sensors to sense data, but the obvious advantage for the Internet of Things is they can work in a cooperative manner and link together. Well, the ubiquity of IoTs provides online supervisory control on objects, and which also allows users to trace and monitor them at any time. Since IoT has been implemented in various industry area and products, those larger such as smart city, transportations, and homes. Those tiny such as tracking goods and collecting one's body figures. The research of this research aims to stepping into the security issues for IoT in the industry and the existing solutions and algorithms provided. So as a result, to introduce, we will introduce a new concept of lightweight cryptography, uh, which is quite different from the traditional ones. Since these algorithms are invented for IoT, which refers to the type of encryption and decryption which includes low-bit microcontroller, use a very small number of gates, low timing, low power requirements, and less memory consumptions. These devices these algorithms are good for the devices like embedded systems and the sensor networks. Since they are very small unit and you cannot put much timing or power on them when you are using them. As a result, These lightweight cryptographies are invented to achieve a low cost and a minimal size. How to achieve a high reliability and of minimal cost in an effective system for the sensor networks is through in a limited chip area is what we looking for, and our focus on the reduction of the size of the encryption key, block encrypted data, and the algorithm's internal state, which is why these algorithms would become lightweight. The first lightweight cryptography I'm researching on is the protocol named as a present. Well, this one is a lightweight block cipher, which is based on SPN, substitution permutation network structure. It considers 64 bits plain text and 80 or 128 bits key taken as input. The cipher has 31 encryption or decryption rounds, and in each round, it will go through one S box, substitution box, and one P box, which is permutation box. In each round, 64-bit key generated from the key register performs XOR operation, which with plain text, and the key register is updated. The algorithm uses 4-bit input and output as boxes in substitution layer or for hardware optimization. Permutation layer is very simple and straightforward. As a result, present is one of the leanest lightweight algorithms, which only needs 1,884 GEs. Well, here GE is stand for the gate equivalent. And the bad thing is it is good at security and performance, but also have a disadvantage of high power consumptions. In the right, in the right of the picture, there is a diagram of the flow diagram of the present cipher. In this same session, the next lightweight cryptography I want to introduce is T, which is also a block cipher and based on Festool network structure with 64 rounds. It works on 64 bits plain text and 128 bits key is used. The key schedule algorithm is very simple. The total 32 rounds used by the algorithm. Key materials are mixed up same way in each cycle, which is demonstrated in the right picture. Various golden constants are added in every round based on the symmetric of the round, which helps to avoid different attack. The GE value of this algorithm is 2883. In the further research, I will step into other lightweight cryptographies like Clefia, C-LED, Hummingbird, and Countdown. Well, these are the all existing algorithms I will look into. Actually every of the algorithms are designed optimized according to a different performance metrics. It's quite difficult to evaluate them, but we should know that there's no such cryptographic algorithm which is best in all circumstances. There are always existing trade-offs between the performance and the security parameters. For evaluation purpose, I will use the following parameters to evaluate those existing algorithms, and finally classify them into two classes. I will talking about conclude them into the disadvantages and the disadvantages. The parameters I'm looking for, uh, the first one is the key sensitivity, which means how many change if it will happen if you change a bit in the key or a bit in the plain text. Um, and the execution time is like a measure for how many rounds you will run for this algorithm and how many time complexity you will take for the hardware or the software to finish one encryption. The memory utilizations is like how many memory you require to run. So typically a little measures of the memory, the better the performance, the better is for this algorithm. And also we have entropy in these algorithms because the encryption algorithms adds additional data normally additional data to the information. The purpose for this entropy is that we need to make the adversary third parties when attack happen difficult to find the real message. So the higher the entropy, better the execution of the security the algorithm is. Very beginning, the purpose of this research is to look into the existing algorithms and help future researchers to analyze and have a brief view about the disadvantage and advantages of them. So thank you for you guys to listen to my presentation, and now we can have a QA session. Thanks, everyone.